Hello everyone, welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I teach you chemistry at this platform for GATE exam. This is our GATE exam syllabus. We have completed section 1 and section 2, and from the last 2 days we are studying about S block elements. So without any further delay, let's begin our topic S block elements. First of all, let's recap something about S block elements, what we have studied in the previous lectures. So we have studied about the S block elements of periodic table, and these S block elements are those in which the last electron enters the outermost S orbital. As the S orbital can accommodate only 2 electrons, 2 groups 1 and 2 belongs to the S block elements. Group 1 of the periodic table consists of lithium, sodium, potassium, rubidium, cesium and francium. As we have discussed about this, they are collectively known as alkali metal because they form hydroxide on reaction with water, which are strongly alkaline in nature, while the elements of group 2 are known as alkaline earth metal, and the exception is beryllium. Beryllium is considered as the group 2 element, but this is not considered as the alkaline earth metal. As you can see, this is your periodic table, and this periodic table has two groups, starting two groups, that is number 1 group and number 2 group. We have studied about the group 1 elements, and in this second group, as you can see, 6 elements are there: beryllium, magnesium, calcium, strontium, barium and radium, in which we do not consider beryllium as the alkaline earth metal, but this is the member of group 2. Now we are going to discuss about the general overview of group 2 elements. So let's begin our general overview. Group 2 consists of the elements beryllium, magnesium, calcium, strontium, barium and radium. These group 2 elements are known as alkaline earth metals because their oxides and hydroxides are alkaline in nature, and these metal oxides are found in the Earth's crust. These metal oxides are found in the Earth's crust. That's why group 2 elements are known as alkaline earth metal. 2 electrons in the outermost shell and general configuration is the Ns2. Group 2 elements has the 2 electrons in their outermost shell. That's why they have the electronic configuration as Ns2 type. In all the group 2 elements, radium is the highly radioactive element. And when you talk about the group 1 element, francium is the only radioactive element with the half-life of 21 minutes. Next, we are going to discuss about the physical properties of group 2 elements. If you talk about the number 1 physical property, that is physical state, all the members or the elements of group 2 are in the color of grayish white, and these group 2 metals are always harder than the alkali metals. These are diamagnetic and colorless in the forms of ions or in the metal state. Next is the atomic size. The atomic size of the group 2 element increases from top to bottom. Means, as you can see, from beryllium to barium, the atomic size of all the elements increases. But the size of group 2 elements are always smaller than the group 1 elements. And you also know that atomic size of the elements depend on the Z effective. And also, if you talk about in all S block elements, beryllium is the smallest while cesium is the biggest element in all the S block elements. Next point is about melting and boiling point. As you know, metallic bond is stronger than first A group elements due to the smaller atomic size and 2 electrons in the valence shell. Hence, melting point and boiling points are higher. Decreasing order of melting and boiling point is this. From beryllium to magnesium, the melting point and boiling point decreases. Melting point and boiling point of calcium, strontium and barium is higher than magnesium. Melting point and boiling point of calcium, strontium and barium is higher than magnesium because of the presence of d orbital in the outermost shell, which forms stronger metallic bond. And also melting and boiling point is directly proportional to the strength of metallic bond. Next, D point is ionization energy. First ionization potential, first ionization energy is higher than the first A group because of the smaller atomic size and completely filled s orbital, while second ionization energy is always less than the first A group of group 2 elements. Decreasing order of ionization energy is this. From beryllium to barium, the ionization energy decreases. Next is the metallic character. As you know, metallic character is always inversely proportional to the ionization energy. When you increases ionization energy, metallic character always decreases. Next point is the density. Density will always increases from Be to Ba. Just focused on this point, guys. This point is very important, and from this point definitely question can be asked. Density always increases from Be to Ba, but the exception is always there in case of density. Density of Be is higher than the calcium and magnesium because of the less volume in comparison to its mass. And the density of magnesium is higher than the calcium. Reason, as you have seen in the group 1 cases, and the reason is the maximum capacity of M shell is 18 electrons, but it contains only 8 electrons, which decreases the density, and order of density becomes this. Now I am showing you what is the correct order for density. You have to learn the order for the density in case of group 2 elements, and the order is this. Calcium density is always less than the magnesium, or you can say magnesium has the higher density than calcium. Magnesium density is less than Be, then Be density is always lesser than strontium, Sr, and the highest density is for Ba. So this is the correct order for density in case of group 2 elements. You have to remember this point. You have to memorize this point. As you know, this is inorganic chemistry, and in inorganic chemistry you have to memorize all the points. You have to do revision on the daily basis. Next is the conductivity. If you talk about conductivity, these group 2 elements are also the good conductor of heat and electricity due to the presence of 2 free electrons. But the conductivity of second A group, the conductivity of group 2 elements are always greater than the group 1 elements. Next is about flame test. If you talk about beryllium and magnesium atoms, due to small size, they bind their electrons more strongly, so are not excited to higher level. Hence, they do not show any flame test. While other elements of group 2 shows the flame test, shows the characteristic color to the flame. And the colors are as follows. For calcium, this is brick red color, strontium, dark red, and for barium, this is green color. Now let's recall the flame test colors of group 1 elements. In case of group 1 element, as you know, we have studied lithium has the crimson red color, sodium has the golden yellow color, potassium has the violet color, rubidium shows the red violet color, while cesium shows the blue color. So you have to memorize all the colors of this flame test. As this point, I point is also important, you have to memorize the colors of all the elements. Next is the photoelectric effect. Group 2 elements do not show any photoelectric effect because the atomic size is small, hence ionization potential is always higher than the first A group. While in case of first A group, cesium is the best element that shows photoelectric effect. That's why cesium is also used in the photocells. Next is the standard oxidation potential. When you talk about the group 2 elements, they have lower values of standard oxidation potential. And reason being is the small size of the group 2 elements. The increasing order of standard oxidation potential is this, as you can see here. From beryllium to barium, the standard oxidation potential increases and tendency to losing electron also increases. Next is the complex formation tendency. Group 2 elements has the less tendency to form complex compounds because they have small size of cations, but beryllium and magnesium has the small size of cations, so form complex compounds. I repeat, group 2 elements has the less tendency to form complex compounds, but beryllium and magnesium has the tendency to form complex compound because they have small size. When you talk about group 1 elements, in case of group 1 elements, lithium is the only element which forms complex compound. Now the next point is very important, as you can see here, the order of standard oxidation potential of S block elements. This series is based on the order of standard oxidation potential in case of all the elements of S block. So you have to memorize this series. Now we have ended up with the physical properties of group 2 elements, and now we are going to study about the chemical properties of group 2 elements. So number 1 is your reactivity. We are going to study about the reactivity of group 2 elements. The elements of group 2 are always less reactive than the alkali metal. As you know, the order of reactivity always increases from top to bottom. That's why the order of reactivity in case of group 2 is this. Be to Ba, the order of reactivity increases. When you talk about the different elements of group 2, beryllium do not show any reaction with hot water, while magnesium shows reaction with hot water, and calcium, strontium and barium reacts even with cold water. Next is the reactivity with air. Except beryllium, all the metals are easily tarnished in air as a layer of oxide is formed on the surface. Barium, when present in powdered form, bursts into flame on exposure to air. When you talk about moist air, when you reacts metal with moist air, except beryllium, all the elements convert into carbonates. While in dry air, beryllium and magnesium gives nitride and oxide both, but other elements will only give oxide. So this is the exception of beryllium and magnesium, that with moist air they always gives both nitride and oxide, while rest all the elements will give oxide in case of group 2 elements. Next is reaction with oxygen. Alkaline earth metal reacts with O2 to form MO type compound or MO type oxide. Here M is your beryllium, magnesium, calcium, strontium or barium. But in case of calcium, strontium and barium, due to the low ionization potential and more reactivity, they will form MO2 type compound even at the low temperature. Example is CaO2, SrO2 and BaO2. The peroxides are always colored due to the lattice effect. BeO will show the amphoteric property. Amphoteric, as you know, they can behave as the metal or non-metal both. Beryllium oxide. Next is the MgO. MgO, magnesium oxide, always acts as the weak base, while rest of the group 2 oxides behave as the strong base. You know it very well, the basic properties of oxides always increases from Be to Ba. From top to bottom, basic properties increases. That's why magnesium is the weak base, while calcium oxide, strontium oxide and barium oxide are the strongest base. Next is reaction with hydrogen. Except beryllium, all the alkaline metal forms MH2 type hydrides. For example, MgH2, CaH2, SrH2 and BaH2. When you heat these MH2 type hydrides of group 2, you will get the directly H2 gas. And the formation of BeH2 is as follows. When you take two molecules of BeCl2 and when you react the BeCl2, two molecules of BeCl2 with LiAlH4, you will get two molecules of BeH2 with LiCl and AlCl3. I repeat, when you want to prepare BeH2, you need two compounds, that is BeCl2 and LiAlH4. You need two molecules of BeCl2. When you react two molecules of BeCl2 with LiAlH4, you will get two molecules of BeH2 with LiCl and with AlCl3. This is the formation of BeH2. BeH2 and MgH2 are covalent compounds, while rest all the metal hydrides are ionic in nature. Next is reaction with water. These metals react slowly with water to form H2 and metal hydroxide. When group 2 metals are reacting with two molecules of water, it will form a compound like MOH whole twice type compound and release of H2 gas. And you have already studied about these elements that Be do not shows any reaction with water. Magnesium only reacts with hot water, while calcium, strontium, barium reacts with cold water. Next is the reaction with halogens or reaction with halides. Alkaline metal reacts with halogen to form Mx2 type metal halides. For example, BeCl2, MgCl2, CaCl2, etc. Now I am going to tell you some important points. Please note down these points. Ba burns in the contact with calcium Cl2. Hydrolytic nature of the halides decreases from BeCl2 to BaCl2. And the order of ionic nature of metal halides of group 2 elements are like this. From BeCl2 to BaCl2, the ionic nature of metal halides always increases, while the metal halides solubility decreases in water from BeCl to BaCl2. These two are the most important points. You have to learn these 2 points. Next is the carbonate formation. All the alkaline metals form MCO3 type carbonates. All the carbonates decomposes on heating. For example, if you are taking BeCO3 and if you heat this BeCO3, you will get BeO plus CO2 gas, and the order of decreasing stability is from BaCO3 to BeCO3. The order of stability of carbonates decreases. Next is the nitrate formation. Alkaline earth metal forms MnO3 whole twice type nitrate. M is your alkaline earth metal. Stability increases from BeNO3 whole twice to BaNO3 whole twice, but these are less stable than the first A group. Next is the formation of amalgam. When you talk about the formation of amalgam, all the elements of group 2 shows the formation of amalgam with mercury. Next is the solubility in liquid ammonia. Only calcium, strontium and barium gives blue color solution due to the ammonicated electrons when dissolved in the liquid ammonia. Beryllium and magnesium are small in size and have a high ionization potential, so they do not dissolve in liquid NH3. Dark blue color of the solution becomes fade if it is allowed to stand for the long time. This is because of the metal amide formation. Blue color of the solution disappears when you add some ammonium salt, as you have seen in the group 1 case, due to the NH3 formation. And on increasing the metal ion concentration, the solution converts into the bronze color due to the cluster formation of metal ions. This is the most important point in both group 1 and group 2, the solubility in liquid ammonia. You have to remember the colors of the solubility in liquid ammonia. As you have seen here, when you dark blue color of solution becomes fade when you allowed this solution for long time, and the reason being is metal amide formation. And here when you increases the metal ion concentration, this will convert into bronze color due to the cluster formation. So now I hope you all are cleared about the group 2 elements. We have seen physical properties and chemical properties and general overview of group 2 alkaline earth metals. Now, in case if you are new here at our YouTube channel Gurmantra Shiksha Ka Granth, please do like, share and subscribe. For further queries, please mail us or you can contact us. And please join our Telegram channel for more new updates related to your exam. You will get free PDF and free notes over there. Thank you very much guys. I hope you liked the video.